This section we're going to talk about differentiation and integration of vector-valued functions. And the definition of the derivative of a vector-valued function, recall, go back to Calc 1 and look at your notes. What's the definition of derivative? Well, that's f prime of t is the limit as h approaches 0 of maybe f of x plus h minus f of x over h, something similar to that. If you notice, this definition of derivative of a vector-valued function looks exactly the same, but there are a few differences that are rather subtle. This r of t plus delta t is a vector, and so is this vector r of t. And therefore our derivative, r prime of t, is also a vector. So the derivative is this, where for all t where such a limit exists, and if it exists at a number c, then r is differentiable at c. If that derivative exists for all c in an open interval I, then r is differentiable on that open interval I, and if that open interval I happens to be all real numbers, you would say r is a differentiable vector-valued function. And this is nice and simple. If you want to define such a derivative, all you have to do is take the derivative of the I component, then the j component, and the k component, and say r prime of t. Say r prime of t is the derivative of f times I plus the derivative of g times j plus the derivative of h times k. In other words, you take the derivative of each of the component functions and multiply them by I, j, and k respectively. And I would say if you don't have a k, if your vector-valued function is only in 2 dimensions, then just the f prime I plus g prime of j is your derivative of your vector-valued function.